Hi everyone. I guess I'll just do a quick introduction. First off, this is not my work, but I will talk about it later. It's very important to the presentation I'm going to give. But my name is Ramon Amaro. I'm a PhD researcher in the Digital Cultures Unit, the Center for Cultural Studies at Goldsmiths in London. I basically study the philosophy of mathematics, both in theory and in application. But mainly what I'm interested in are automated processes and machine learning, and artificial intelligence, and I deal with the ethics associated with the training data that goes to power those particular systems. It sounds like quite a convoluted project, but eventually will actually end up in a doctoral project. And I'm at the very beginning stages of working on training the machine to be racist. And the second phase of that project will actually look at mechanisms where the machine itself can determine whether it wants to be racist or not, which is the next sort of iterative phase of automated learning and artificial intelligence. And if anyone's familiar in the room, which I'm sure you all are, most significant research at this point, Google's DeepMind, some things out of Delphi, Microsoft, and so forth, are just at the beginning of sort of toddler phases of artificial intelligence, which is they're just now the machine itself is just now recognizing its own sort of sensory mechanisms. It can dream, it can determine its own classification and its own images, just like a toddler would. We're still many years away. But the next iterative step is that the machine itself will be able to take its own input data, train itself to make implicit conclusions, and then act upon those conclusions will become the input to the next iteration of its training. It's a self-adaptive process. But I want to start this talk with basically a short description of a few projects that are a few years old at this point. The first and second are conceptual works by artists Keith and Mindy Obadicki called The Interaction of Colors, that's this one here, and Keith Obadicki's Blackness. The final project I'd like to discuss is a research experiment actually conducted by Dr. LaTanya Sweeney, who's the director of the Data Privacy Lab at Arbor, on the social implications of Google AdSense. So basically, I'm going to switch from basically conceptual artwork on how data itself engages with the subjective, and within this framework is the subjective as difference, which I frame as blackness itself. And then I'm going to move on to actual empirical experiments to show how this actually plays itself out within the neutrality of things that we, data-driven mechanisms that we work with on an everyday basis, such as search, such as learning algorithms as your Facebook feed, so on and so forth. But really what I want to do is, I don't want to talk actually too long because I would like to interact in more, like perhaps we can talk about these issues together in the limited space that we have. Maybe we can have questions and have some kind of dialogue. So we're going to try to speed through this and be done with it so we can talk about this issue that's very important to all of us, I'm sure. I'm also hoping that this discussion will move beyond sort of the delineation of disciplines that we all love, disciplines between, actual designer and engineer, planner, process. My research lives within those. I'm an engineer, actually a mechanical engineer, so I designed hardware and moved on to social sciences, and so I'm in this really weird sort of space. And now that I'm in ethics, I'm kind of like the dick that stops productions. So it's not often a fun place to be. But anyway, really those in-between spaces is really what I consider, they hold a sort of unseen yet explicitly clear violences that sort of reveal themselves in data-dependent web and design practices. I use the word violence here kind of intentionally. It's a strong word that few would associate with sort of a matrix of data practices, especially with design and coding practices. After all, we are just talking about code. We are just talking about data. But I believe that violence is a necessary description I believe abundance is a necessary description of the possible residual effects of the data practices that we all engage in, and that we don't carefully consider the cultural circumstances that go to inform the data that we input or use for training purposes, and how those interactions with our digital applications are still infused with sort of cultural biases, even when those technologies or the designers themselves are not aware of the cultural implications of the products that they provide. My concern here then is sort of twofold. The first is how can theories behind maths and the digital practices that they power inform certain rationalities and ideas concerning the development of an ideal agency? That's a pretty important question. And I think what I mean is, like, how did the maths that inform our coding languages that we use today and the algorithms that we design, and the practices that come from those, like, how are they determined through predetermined logics and predetermined data and things that we sort of take for granted? And is there a conflict between how the maths themselves were produced and how they historically have been applied to social situations? And maybe one sort of survey, if you're not embarrassed to do it, is who in here is good at maths? Who's really solid at it, right? So who actually designs codes, machine learning, deep mining, so on and so forth. So it's kind of mixed in there. A lot of, basically, essentially what I'm trying to point out is a lot of the technologies that we use are fundamentally based on historically developed mathematical processes, and all the math people know this. One particular example is linear regression, Bayesian probability, so on and so forth. Now, these tools have become mechanisms that we take for granted when we design algorithms, is particularly learning algorithms, even when we're designing sort of self-sufficient processes and practices. We're actually engaging with the maths of those practices, because within is the code behind the learning language. And it's all driven by mathematics, which is why I'm in that sort of, that particular space. But where there could be a possible tension between the two, I'll use like one sort of particular example, and that's sort of the genealogy of statistical regression and Bayesian probabilities. Does anyone know what regression is? Yeah, a little bit, right? Stars in this room, right? But basically, statistical regression basically takes a massive amount of sensory data essential to deep mining processes, the things that make your Facebook algorithm, newsfeed work, the things that make search work. This is basically a statistical and mathematical tool, put simply, that can simplify massive amounts of data into generalized probabilities. And what I mean by that is anyone who's dealt with any severe, any massive amounts of coding or massive amounts of data will understand how important it is, given hardware limitations, software limitations, money, servers, databases, given all those limitations, basically what we're designing needs to be simplified so that we can increase processing speed, so that we can increase usability, so on and so forth. And statistical regression is a mathematical tool that allows it to do so. And it basically is based on normalizing behaviors. And it makes no sense for math nerds on the basically, there's no time to go into the specifics of how that works here, but I'll just give a quick genealogy of the logics that contribute to how we do things today. Basically, linear regression came about through Poisson's experimentation with jury decisions. And would you imagine that your Facebook newsfeed is fundamentally based on technologies that developed to try to predict jury decisions? It's pretty abstract, isn't it? I mean, we are talking about sort of the early 19th century. But basically, his experimentations went on and led to a very important book, which is called The Law of Large Numbers, which was in 1837. And it's really sort of a baseline for quantitative research. The law of large numbers applies statistical tests to deduce rare events like jury decisions into probabilities of certain outcomes, making it possible basically to incorporate variability into generalization. What does that all mean? Basically today, what a long progression of this technology enables things like facial recognition to do, or image recognition. We all hear that now. Google, every time they do make a breakthrough in images, they're like, we can read numbers. And that's because they basically trained the machine through variability of different images of state like the number 1. And the machine itself can deduce and normalize those images into one sort of what it thinks one might be. And that's a generalized baseline. This came from the genealogy of practices, of course, with jury decisions. If we can sort of normalize the variability of human decision-making into one sort of predictive mechanism, then we can determine whether the jury decision is valid or not. One important thing to note is that when these technologies were being developed, these sort of probabilities as degrees of belief were considered sort of judgments by rational beings. They were considered things that sort of, they were starting points to evaluate whether something was valid. So if I put all of you in one room, I can basically statistically come to a normalized curve, which is regression. And that's sort of a sense of behavior that you all would do based on certain sort of mechanisms. The problem comes in sort of in the 19th century with our obsession with data, which we actually see at height right now, our obsession with quantification and data. And really what came about that is applying those same tools to social behaviors. And it's had very devastating effects throughout history, which is why strangely enough, packaged in different apparatuses, so this, voice recognition, Facebook newsfeed, so on and so forth, is quite strange because these technologies were tested out on humans. And they were tested out in the aspect of race. They were tested out with histories of eugenics. They were tested out with populations with poverty, trying to predict how much the average family in poverty, how many children they might have, how many resources they might need. And so you can see the human body sort of being statistically put into a normalization of what that human being may be. And this sort of elicits certain sort of reactions. And I apologize here because I'm kind of bouncing back and forth. This is a big topic and there's not enough time to go through it. But one living example of the normalization through statistical processes, especially as we think about data, is this understanding that when we think about data, when we think about the tools that we use, we have this implicit assumption that the machine is objective. It's just an algorithm. The algorithm tells me that 15 people will do this, or that this will happen. It's just a line of code. It's just a piece of data. But what we're not properly considering is the fact that that data is already infused with the cultural circumstances that we currently have. The data is never raw data because the data itself is produced on points that are already biased and skewed. And those points come in the form of racism, they come in the form of sexism, they come in the form of homophobia, they come in all those cultural apparatuses. We see that probably particularly in like police stop and search, where we create sort of an echo chamber. And I think Stefan talked a little bit, he sort of was getting there with talking about death practices online, this sort of echo chamber. Basically, and we see more jurisdictions now, I'm not sure here in London, they're spread everywhere like wildfire. We see more jurisdictions that say we have problems with police in minority communities. So what we're going to do is we're going to elicit an algorithm to tell us where it's efficient enough to deploy police. What we're not considering is that algorithm is based on training data that's already infused with racial mechanisms. And it becomes an echo chamber because what I do is I say I can pop out a very normalized curve that basically says, and this was actually data, is data from 2014 in Lewisham, where I live in London, and it's a huge sort of police stop and search hotspot. So what happens is the police stop and search with this in this objective process, right? So they say, you come here and I'm going to search you. When they search you, they actually encode your race. I know I'm a C3, I just happen to know that because I have a friend that's on the committee. And C3, actually, I've learned that the London Met only has 3 categories. They have black, non-black, and other. So you're already input as, I would be input as a C3. That C3 becomes a data point, a living data point that never dies. I have now been recorded as a C3 in Lewisham of London. That C3 goes into a normalized regression. It goes into an algorithm. That algorithm says there's another black male who's been stopped and searched. You see how it's But the algorithm itself, if we consider it objective, I have no human input. the officers have no flyability, the algorithm says it's been deployed where it's been deployed. What's interesting about the data, though, is when you look at the data and you look at the number of stop and search for black males and the number of arrests, if you look at the actual raw data, if they actually stopped the same number of non-black people, they would have the same number of arrests. So the echo is a complete illusion. So, and we're starting to see this now. I think there's just an article that came out today about how Google search may be influencing elections by showing you certain types of data, because the idea is subjective. I'm just feeding back to you the data that you're inputting into the system. Or if you have tons of friends that are already against a certain candidate, then it can be statistically regressed back to you. Another good example are new gang policies that are happening in London right now, which are using statistical probabilities that basically power drones at this point too, which is interesting about today. And what that statistical probability basically says is the algorithm says you. So I'm gonna pick on you for a second. So the probability says I can do input data that say we are here right now. So there's a statistical probability, and math nerds jump in. There's a statistical probability that I might know you. I'm not good enough at math to say what the probability is. So let's say later on tonight, we both go to the same train. That probability that we know each other just got better. Let's say we ended up actually on the same street. The probability that we know each other just got more and more high. This is basically the reductive part of how drone technologies work. So basically the technology itself is saying that I know you. Now how is this applied in a practical situation? Well, London Met has a new law now in London where any associated gang member automatically circumvents the legal process and goes immediately to prosecution. How they're determining that is they're determining that by data and algorithms. So if I'm a gang member and you're not, guess what? You're also a gang member. And so basically these sort of laws are sort of circumventing our idea of freedom, like something like Jeremy said, it's in a slightly different package. But I do want to jump ahead because I'm running out of time here. But basically this is kind of an experiment that I would urge you to sort of engage with on your own time. But these are just media artists, Keith and Mandy Obadeki. And basically, one of the projects they've developed very early on is sort of a color chat system on how to develop your own web-safe color. It's really cool, actually. So I don't know if it's working now, but it used to work. But you input all of these data characteristics that we love to volunteer today. Do you have freckles? What height are you? What weight are you? What color are your friends? So on and so forth. And then it spits out a hex code at you as your color safe hex code. And it's supposed to be sort of very play on the interactions of social subjective mechanisms with the data that we encounter. Due to the time, I'm going to skip over to another project, which is what Keith Obadeki did. He actually sold his blackness on eBay. This is real. No, it's real. The bids he got here are actually real. He almost got sold for $152. They eventually took it down because they realized it was a joke. But if you really read the descriptions here, it's sort of the fundamental basis of how we engage with the practices that we've become taken for granted today. And you can see he's sort of like highlighting what the actual, his concept of the black body is used for. And really the theories that we're driving for is kind of what Jeremy was alluding to in a certain sense, is we really have to start questioning ourselves. No matter what your discipline is, as a practitioner, as a designer, as an engineer, we have to start questioning ourselves on how these mechanisms are taking away our subjective being. And how our subjective being is being replaced by the projection, the regression, basically. The projection and probability of who we should be or who we could. I want my Facebook to work. I like cat videos. I'm not ashamed to say that. I want to see these things. We want our mechanisms to work. I can imagine a world with self-driving vehicles because it's just a nightmare. You can imagine these sort of things that work for us. The problem is, if we don't address these ethical situations early enough, we can end up with instances that just recently happened where the son of a known terrorist attack was actually the target of a drone. And he was actually targeted based on body movements and certain behaviors that said that he might follow in his father's footsteps. And we have to consider the fact that human lives are being taken, people are being incarcerated, and other sort of very, very implicit and nasty things that are happening based on basically what Jeremy is saying, on instances that never actually happened. And what we're doing is we're circumventing due process. And what I mean by that is we're driving ourselves into a data world where it's not so much that the prosecutor or so on and so forth has to prove my guilt. I have to prove my innocence through my data. So I have to prove statistically that we don't know each other, as opposed to the burden of proof being with the state or so on and so forth. And again, it's not all doom and gloom, but I think there's something that we have to consider, particularly with the design practices. And, you know, especially if we consider something like Google at this point, who really can't keep up with their ethical issues. We have very severe instances. One I want to talk about, which is an academic experiment by Dr. Sweeney, who basically found that when you type in a black-sounding name, the online display ads would say, "Have you been arrested?" But when you typed in a white-sounding name, whatever that is, the display ad would say, "Look up their profile." Now, what's the first thing you do when you go apply for a job? What's the first thing they do? Google you. And basically, her point is, basically, if you've been Googled, then the first thing that pops up is, have you been arrested? Whether you have an arrest record or not, it has a very explicit relationship with your future potential, whether you have or not. And there's no law to actually protect you from that mechanism. And as a result of that study, Google actually did an update to their algorithm. But they're finding themselves in different sort of very tricky situations. They just found out a few months ago that if you typed in the N-word, Google Maps would send you to the White House. Right? These aren't intentional designs, right? I highly doubt these are intentional designs, but they are mechanisms that are there. Flickr was very proud of their new facial recognition software. They're auto-tagging of photos. It's a very difficult thing to do. What they didn't anticipate is that they would categorize a black woman under monkeys. And this is why these sort of mechanisms, now these are the things we just know. Imagine what hasn't come yet. So we could see, especially as practitioners, and I consider myself one, even in the ethical way. I'm the annoying one that says stop. I consider myself a practitioner. We've come into an exploratory space where now we can no longer just explore. We have to preempt. And we can't preempt subjectivity. What we have to preempt is contingency and possibility. And understand that the mathematics are there as a process, but the mathematics also have a residual, a real life residual that doesn't make, who really gets upset if your Netflix recommendations are off by something. You really hate Tom Cruise and it pops something like that. I mean, come on, we don't want to riot over that. But if somehow a recommendation system will prohibit you from flying or will solicit a drone attack, there's very little pliability and very little accountability. I mean, before I stop speaking on the seriousness of it, got me started. I recently just learned that it takes 127 people to operate a drone. 127. So if that drone, which is very interesting to the experiment today, if that drone makes an improper decision to target a young person or inappropriate person, there's no accountability within those 127 people. Yet we look to the drone as if it's making the proper decisions. And that's sort of kind of what I want to end on. And maybe we can open up to questions and comments. And maybe I'd love to hear what you guys think about all of these sort of drab things.
When you've been exposed and you've worked with data for a while, you realize one thing that is quite clear, and that's that data is never either perfect or complete. Yeah. And the completeness of a data set is what determines the validity or what determines the validity of the decisions. And yet this is never actually openly discussed.
Right.
The immense majority of the data sets that are collected and analyzed are reliant on incomplete information.
Of course. And that's why it's put extra responsibility on the researcher who is you. Because you know why? Because if you look at most quantitative research, especially in the social sciences, they're very much self-aware. If you actually read the study, it says, maybe this would happen. There's a high chance that 14-year-old girls might be bulimic. As soon as that study gets in the hands of politics, it becomes 14-year-old girls are bulimic. It becomes a law. It becomes a rule of culture. So obviously these things have to, the data is never perfect, and the practitioner knows this, obviously. And that's why these tools such as regression and probability are there to help reduce error and to help determine and put this down to a scalable thing. If not, we wouldn't be able to do it, right?
The way that this has been played out in the political landscape is that the President of the United States signs off for every single execution that takes place through a drone. So the way politicians have played this is that, we don't only use statistical analysis in order to come up with the kill list. The kill list has to be signed off. But the processes by which this happens, or that the President certifies that this is the case, are not transparent at all.
Right. Well, we're back in the black box system, aren't we? Because these actual mechanisms are, because we don't actually know how the president makes that decision, do we? We just know he makes it. And we don't actually know that once that decision is made, what intelligence and data it's being based on. We also don't know what sort of adjacent processes of deployment actually go into that sort of process. But that's why I'm in sort of this hybrid space of the logics, because that's the same logics that most police departments use. Is even if I use an algorithm, I have an officer with 10 years experience that can tell a criminal from me. You see, they're sort of filling all the loopholes, basically. And we should know this historically, that when certain mechanisms of power-producing organizations start to fill loopholes, we should be very scared. Because these will have devastating effects on our idea of freedom and idea of being human beings. But I absolutely agree with you. There really is no relationship between the logics of how technologies are communicated and the actual application of them. There are very few logics.
Do you find that this reinforces prejudice?
I don't think it reinforces the prejudice. I think it's dangerous, because what it does is it gives the impression that prejudice can be regressed, that prejudice can actually be systematized and taken out of the system and forgiven away. It's basically saying, I don't trust anyone in this room, so I'll use an algorithm to make the decision. But the algorithm is based on everyone's opinion. You see? So it's basically just bulking responsibility. I think that's what I'm saying. It's basically just passing the ball and saying, okay, these things don't really exist because we're taking the human element out of it. So I think it's more dangerous than actually reproductive.
But historically, that's a known story, right?
Well,
people have been using statistics.
But that's the problem, is prior to the Prussian Empire, because statistics have only been around since the 1600s, and statisticians, they collected data just for exploratory processes, which is how people code nowadays and design. They were exploring, it was only until, I think it was Laplace who basically in the Prussian Empire went to the government and said, you know what, I have something. I can collect data on everyone in the country, and at that time it was determined if I can actually statistically determine how many males are in the empire, I can determine the strength of the empire. And this was actually the birth of the black box system too, because eventually the Prussian Empire realized that, wait a minute, if I have data on my country, my enemy can have data on my country too, thus the birth of government secrecy.
And also sociology.
And also sociology, because sociology was born from the fact that of using pretty much random data. I mean, we're talking about data on cows and, how much cows eat, how tall men are, and, how many children women have. We're talking about this type of data. I mean, when Durkheim got his hands on it, basically, is when those tools start to become studies of culture. And it's within those studies of culture where they start, inner Darwin, inner eugenics, where they start ranking culture. They start looking at pliabilities of culture, and that's where the sort of, you're right, that's where those ideas of basically how can we statistically improve culture. And if you don't know, that's basically the fundamental process of eugenics, which is the birth of fascism. How can we statistically improve characteristics of a certain being into an ideal agency? That's basically what we're doing.
Hey, I was just more thinking about the whole building of smart cities and the idea of extinction and everything that takes place. But it's a very utopian idea, and like everybody I talk to who actually works with data or is more critical is like, well, data is always very limited, and you can't make a smart city, or at least not an educated city. But in what way is it related to the belief that was there in the 70s of like that you could create the perfect society? And how do you see these movements? I'd like to hear your perspective.
I see them in the archive, which is what Stefan, I think, was sort of getting to, which is, I mean, in a way, the NSA was perfectly correct. Remember the NSA said, people, what's the big deal about us spying on you? We can't process this amount of data anyway. They're right. We don't have the database technology to process the massive amounts of information that they're going. What they're not telling us is that they're storing it for future viability, so they can build a profile retrospectively. And I think that's the difference between sort of 70s practices and today. Is back in the 70s, of course, we can still speculate and we can still sort of project and preempt, but it was very difficult to build a profile retrospectively. Like, when you think about the 70s, think about Nixon. We welcome that today. They impeached him for this. And now we sort of ask for it in exchange for, YouTube videos, which I think are great. But, so I see the sort of the relationship as being where, and I don't want to give an impression that like this data paranoia, we should be afraid of data, we should be afraid of all these things, or like, hide our tracks. I think there are very specific uses for these things. What I want to make sure of, sort of with my research and my career, is that we keep these things in mind. Because, if we look back at, 16th, 17th century, when positivism, when this sort of idea of quantified data, there was at least a subjective component. At that point, it was religion, who fought back. So there was a tug of war between quantitative and qualitative ideas. If we look at society today, there's no more tug of war. It just is. And that's where I think the debates and discourse, because real progress happens when we're able to get in the room and have a tug of war so that we can leave as different subjects. But when there's no tug of war, we're basically just sponges. And I think that's where it gets dangerous.
We have time for like 1 or 2 more questions.
One thing you said, if I'm using is because logical that algorithms are based on past data. So data collected in the past.
Right.
And now this is actually used in politics as a kind of what will happen in the future.
Mm-hmm.
But if you think about it, then you're actually looking into the past and regressing into past patterns.
Right.
Then again, how can you scientifically gather data from the future? So how is it vision related to politics, where you want people with vision, not looking back, reforming pre-existing conditions?
I think that's like a difficult question. And if you can solve that, call me and write at the end of my dissertation. But I think one of the issues where I'm leading to is a sort of decisional framework based on transparency. Let's call it what it is. We don't need to keep changing the definition of things to mask what we have. I'm picking on London a lot, but London has recently changed the definition of child poverty. Okay. So the poverty is still there. We've just changed the definition of it. So concerning the state, all these people sort of drop off because they're no longer considered poverty. Where that goes to sort of the algorithm is calling it out for the sort of the sensitivity that it does have. It's sort of the sensitivity that you have in Amsterdam when anyone talks about why you don't have a subway. Why? This place is built on water. And it's very explicit. And it's very explicit in how you discuss the infrastructure of what you're sort of building. Now it's limited because what are you supposed to do? You can't take away the law of water, but at least you have a contingency to come up with something creative, which you obviously have because you have an infrastructure on water. But that was built on contingency. That was built on whoever came here and said, I need to build a building, and said, oh shit, it's wet. and that process happens. So where the algorithm comes in is if we keep in mind that back to the olden days, that data is contingency, it opens up a creative space for different possibilities. But if we keep considering data as absolute scientific proof, we're basically foreclosing our own sense of subjective creativity. I think that's what I'm kind of looking at.
Yeah. I just wanted to hear about your AI and racism project.
Yeah, so basically I'm in the beginning stages of I'm in the beginning of stages of, I deal with a lot of the philosophies of math. So basically my research question is, given the available data and given the choice, can a machine learn to be racist? And it's based on AI mechanisms now, such as Google's self-driving car, which by the way has been in 13 accidents and none of them are the fault of the car. But anyway, Google, I'll describe this and describe what the project is. Anyway, Google's car, does anyone know it actually encountered another self-driving car? Yeah, by accident, did not predict it. So it came down the street, I think one from Delphi came down the street, and they both did maneuvering mechanisms to avoid each other, which is exactly the data that they both have as a goal, right? So basically the automobile made a choice, and really the only thing that's holding back the self-driving car, which by the way, this is why they want so much data on Google Maps, it's for the car, it's not for you. So, is the decisional framework, the number one question that they have is, do I protect the passenger or do I protect the pedestrian? It's back to that old philosophy question of, do I kill the one person on the track or do I kill the 15? That's the ethical hurdle that they're trying to get over. So if the car has to read its sensory data, self-learn, and make a decision on whether to go in lane A or go in lane B, my question is, if that same machine, that same technology can read our cultural information, how would it decide? So, because right now, if I'm in the United States, based on cultural information, if I'm a machine and I figure out that my passenger is a black male, I kill him. Because his life doesn't have as much value. You see? So that's where I'm sort of going is, if we leave the automation up to the machine without considering that the machine's sensory data is affected by our own cultural madness, how will it actually decide? We assume it will just decide on like passenger safety or so on and so forth. But we have to take into account that it may actually take other sensory data. Like, could you imagine, I think there's an article in Wired, could you imagine if the machine read all of, fascist collections? If that was the only exposure it had to data? Now, what's even more scary is that's probably not possible, but it will have exposure to that. It will have exposure to it. It will have exposure to racism, it will have exposure to homophobia, it will have exposure, and it will have exposure that's objective exposure. So we would have objective data that basically says that females get paid less in the workplace than males. So when it makes a decisional framework to turn the temperature, because there's a new study that basically says most temperatures in offices are designed for male bodies. So if I leave an automated system to determine the temperature, it's already telling me based on statistical data that women don't have as much value as men, so I just leave it at this. So it's those sort of mechanisms, and obviously it's a very huge project to deal with.
Thank you so much.